Okay, ready for an intense review of graphing trig functions? So the first thing I taught you was sine versus cosine. Here's 0, here's 2 pi. Try to fill in all the labels here. You need to do this on paper or virtual paper. You can't just watch me. So go grab your notes, grab something to write on, and try this, and I'll have you pause and come back. All right. Some of you guys aren't actually doing these. You're not going to do as well on the test. All right. This is 3 pi over 2. This one's 1, and this one's -1. So that's the graph of sine. And yes, it goes forever in both directions. So its domain is all reals. And its range, well, the lowest it goes is -1, and the highest it goes is 1. All right. So that was our sine graph. And then cosine was similar. So sine looks like this. Starts at 1. And I like to do cosine in 4 parts. So it starts here. Let's see if you can do it. I'd like you to pause and give this one a shot. Try cosine. Okay, you're back. And hopefully there's 4 spots that you need to have labeled along here. If you count the first one, it could be 5. And this one is pi over 2. This one's 2 pi over 2, which is the same as pi, 3 pi over 2, and 4 pi over 2, which is the same as 2 pi. And cosine is the one that starts by going down, and then it flattens out, goes down to -1, and then it starts going up, and it gets to 3 pi over 2, and then it ends at 2 pi. Not beautiful, but I would have given you credit, so give me credit, huh? All right, so there's cosine, and its range is from -1 to 1, and its domain is all reals also, because it keeps going in both directions forever, from the left to the right. All right, so that's cosine. Now let's get tangent. What is tangent's base graph? Because if you don't know these base graphs, how are you supposed to graph the more complicated tangent? All right, so everybody write down what you think tangent would look like. Hint, it's got asymptotes. I'm trying to remember where those were. All right, pause me and resume. Okay, tangent goes like this. And at halfway to the asymptote is an important spot. That's where it hits 1. Halfway to the other asymptote, that's where it hits -1. Okay, and then the asymptotes are really important. Pi over 2 and -pi over 2. And all of our graphs start with these things, and then we mutate them and say, oh, I didn't really want you to do tangent. I wanted you to do 2 tangent of 3 theta or whatever. Okay, we'll get into those transformations in a minute, but then we need to go back and do some, this was tangent, hold on. I suppose I should label each of these. This one was cosine, and this one was sine. All right, then we got into the sister functions. So if I was going to do cosecant, I'm going to save some time and draw it right on top of sine. Cosecant had wherever sine hit 0, which is in those 3 spots, cosecant would have to be an asymptote. It can't exist there. Why? Because cosecant is 1 over sine. And if you're 1 over sine and sine turns to 0, you all of a sudden have got 1 over 0, which is impossible. That's why there's asymptotes there. So this one is what the graph of cosecant looks like, super quick. And its asymptotes are 0, pi, and 2 pi. And it's got a complete up cycle and a complete down cycle. When you're done with both of those, then its period is done, and its period is 2 pi. All right, then writing on the back of the sister function cosine is secant, and secant has asymptotes too, wherever cosine hit 0. Okay, so then now I'm going to put in the little loops that go like this. And that roughly is the graph of secant. Now, I didn't do just one period here because I have 2 up cycles and 1 down. So if you wanted to narrow it down to just one period, you'd like cut it off here and cut it off here. And what's in between there, maybe I'll make it green now. That's the graph of secant, the sister function of cosine. Then tangent. Tangent and cotangent, it's not real nice to put them on the same graph because it's going to be really confusing. So I'm going to make a cotangent graph be separate. But looking back at the tangent graph, since cotangent is 1 over tangent, do you see tangent is hitting right here at 0? And so that means there's an asymptote at 0 for the cotangent graph. All right, so if this is going to be y equals cotangent of x, it's got an asymptote there and an asymptote here. And do you remember that for tangent and cotangent, the period is pi? The total distance all the way across, like here, to complete one cycle is 1 pi. Half a pi here and half a pi here. Well, this has 1 pi also for its, for cotangent's period. And cotangent goes down as you go from left to right. I did not draw that beautifully, but it would be okay if you did that on a test. I'd take it as long as these were labeled properly. All right, and then we still say it goes up 1 and down -1 at halfway in between here. Okay, so halfway between where it touches 0 and pi, it also goes down to -1. And this should have more of a curve right here. But okay, so there's the all of the base graphs that you have to know. Next, let's talk about when you got to do something more complicated. Like for instance, y equals negative 2 cosine of theta minus pi. There would be a pretty complicated one. So first off, I think you should try it. We're in the review for the test. Act like that's the test question. Start by graphing cosine. And if you can't do it right now, what makes you think you're going to be able to do it on the test? All right, pause me, give it a shot. Okay, so in this one, first I have to graph cosine. Cosine starts at 1, and I always just do the same original graph. Pi over 2, pi, 3 pi over 2, and 2 pi. And you might be like, but it's got this and this. I'll do those later. To start with, I just graph normal cosine. And let's say it goes down about the same amount here, -1. That's where -1 would be. I'm going to use the eraser because I don't really want to point there. Okay. And now I'll graph it in red. Here's my cosine graph. There. Okay. Now, to get this right on the test, that's how I'd start. But then I do have to make some changes. That 2 means that it's going to go up to 2 and down to -2. Okay, that was the amplitude. That's the distance from here to here, you know. All right, so now, how about that negative? Ooh, that negative is going to make the whole thing flip. And so it's going to go like this. It is a reflection over the x-axis. There. Now I've handled this negative here. And then last but not least, it has to do a phase shift. It's going to go to the right pi. All right. So now, if I phase shift this to the right pi, how far is pi? Pi is that far. I want to grab my green graph and move it over exactly that far. Let's see if I can get a hold of my green graph. Well, I can, but I'm going to move the other one with it. But I guess that's okay. So I'm going to move this over. How far? I'm looking at the lowest spot on the graph, the furthest left on the green graph, and that's where it's touching the y-axis. I'm going to move that over until I've gone over pi. There. Okay. Now remember, that red one was just there to help me make that was the original, right? And so I'm just going to erase off that original red graph. And now the green one that's left behind is my answer. Now, one more thing. I need to label here. So I should label where this and this, what those are. And it's much easier to just count up by 1 pi over 2, 2 pi over 2. This one was 3 pi over 2. This is 4 pi over 2, same as 2 pi. 5 pi over 2, 6 pi over 2. There. Now I've labeled it properly. The whole graph needs to be labeled, right? And I have this green graph extending way beyond 2 pi, so I needed to label it there. And these, remember, have been replaced with a 2 and a negative 2. They just kind of slid over by accident. So there you go. There's an example of that type of a change. Now we're going to do one more where we're talking about how if there was a number here, how that would change it. All right, so let's do that. Let's do tangent. The number in front, I think you all know, if I have a number in front of tangent, it's going to be super simple. I'm just going to change the y-axis from a 1 and a negative 1 to a 5 and a negative 5. But this is where it's going to get more complicated. Let's say that I have a 2 here in front of the x. Now that one has a different period than tangent would normally have. Tangent's period normally is pi. The period is pi over b. And you might be like, wait a minute, you always said it's 2 pi over b. That's because usually we were using sine and cosine and the sister functions of those. But for tangent, the period is pi. All right, so let's see how this thing would look. Tangent normally, remember, I always encourage you to graph the parent first. So here's what tangent normally looks like, and it goes from pi over 2 to negative pi over 2. All right. Now, it's got a spot here and here that used to be 1 and negative 1, where it's about halfway, in between there. And there we go. And now I'm going to change that because of this 5. That's the easy part. 5 here, negative 5 there. Okay. Now, because of this 2, I need to relabel. And what used to be, what's halfway between pi over 2 and 0 here? It's half of pi over 2, which is pi over 4. I can think it take and multiply by 1/2 to get that pi over 4. And this will be negative pi over 4. But all of those are going to change because of this 2 here. Because of that 2 there, I need to change these x labels, and I don't double them. Seems like I would, but remember, when you're on the inside, you do the opposite of what you would think. And so I don't double them. I times them all by 1/2. And then that will leave me with, and you would need to clean this up. I wouldn't have marked this right for myself unless I did this. That turns into pi over 4. This one turns into pi over 8. This is still 0. This is negative pi over 8. And this is negative pi over 4. There. Now, a follow-up question. Pay attention now. If my asymptote is at pi over 4, when would the next asymptote be? A lot of people are just going to say, well, another pi over 4, because this asymptote's at pi over 4, so just add one more pi over 4. But no. The period of this thing is how far it is between asymptotes. It's not just pi over 4. It would be 2 pi over 4 in between the asymptotes. 1 pi over 4 this way and another one this way makes a total of 2 pi over 4. So that's when the next asymptote will hit, is when you're over 2 pi over 4. Now, why are you not saying pi over 2, Mr. Server? That reduces to pi over 2. Because I have pi over 4 here, so when's the next asymptote going to be? I'm going to add 2 pi over 4, and that makes it 3 pi over 4. Okay. So, to do a follow-up on that, just to asking where the asymptotes on tangent are, I'm going to ask you to try this one. If I just gave you tangent of x, where would the first 2 asymptotes be? Well, I know. Here and here. regular tangent, it's pi over 2 and negative pi over 2. But what I mean is, where's the next asymptote? And the next asymptote, where are those going to be? I'd encourage you to pause me for a second and give that a try. Okay, so how far apart are these things? Kids that don't understand this are just going to keep adding pi over 2. But you're actually, how far between asymptotes? Pi over 2 plus another pi over 2 is 2 pi over 2. That's how far apart the asymptotes are. So 2 pi over 2. That is the same as pi. But I'm going to say it's 2 pi over 2 because then it's easier to add pi over 2 plus 2 pi over 2 makes 3 pi over 2. And where would the next asymptote be? Another 2 pi over 2 gets added. And then I'm at 5 pi over 2. All right, so that's how you figure out where the asymptotes are by going over its period distance. All right. Next topic is, let's say that we wanted to do one of these problems where I've given you a low and a high spot. And when you get the low and the high spot, you can tell an equation for anything. All right, so let's say at its lowest spot, this thing was at 3 feet away from you. Maybe it's a hawk that's flying back and forth, like protecting its nest, and it comes up to within 3 feet and then flies away from you to, let's say, 27 feet away from you at its furthest feet away. Okay. And then it comes back at you, gets up to 3 feet away, and then, so anyway, you can tell that this is kind of like a wave, and we call this a sinusoidal. Let's say this happens at 1 second, he was 3 feet away from you, and then at 4 seconds later, he's 27 feet away, and then that cycle, just pattern happens over and over and over. Try writing a cosine equation for this, and I'm going to pause for a second while you figure that out. Okay, hopefully you've given this a shot on your own. It's the only way to learn it. So I'm going to go cosine. I got to put something in front of it. The amplitude. I'm going to need numbers in the middle and numbers at the end, but I'm going to just start by saying cosine. All right. I hope you remember that the thing I suggested you do first was this midline. Okay, and what's exactly between 27 and 3? If I add up to 27 and 3, it makes 30. Half of that's 15. That's 15. It's exactly between 3 and 27. Double checking that, I just add 12. The distance here is 12 and 12. And oh, that happens to be the amplitude. All right, so the amplitude is from the 15 to the 27, which is 12. And then the amplitude, the midline was at 15. That goes at the end. Now, the hardest part is the stuff in the middle. And that's where you're going to need your x minus, and how far do we shift over? I hope you said that's where the cosine is supposed to start, is at 0. How far is it shifted over? It's shifted over 4 spots. So there's a 4 right there. And then last but not least, I need that number. That's the b. And so that is, period is 2 pi over b. Wasn't I just using pi over b a second ago? Yeah, but we're doing cosine. So its period is 2 pi over b. And I don't know the b. That's the point. I want to figure it out. Well, how far is the period? So many kids are just going to go, 4 minus 1 is 3. The period is 3. No, it doesn't complete a complete cycle over the course of 3 seconds. It does it over 6 seconds. Okay, so then that's 6, and I can reverse the b and the 6, and so b is equal to 2 pi over 6, which simplifies to pi over 3, and that's what goes right here. The b term that goes right there is pi over 3. All right, now, to sum it all up, this is 12 is the amplitude. By the way, if there'd been a negative in front, 12 would still be the amplitude. Amplitudes can't be negative. Pi over 3 is the b term, and that's also known as a horizontal. And remember, if it's a fraction that's less than 1, then it seems like it's shrinking, but it's actually stretching. X minus 4. And then this is the phase shift, and it was to the right 4. And last but not least, that's the midline. It's also the vertical shift. It's how far up this function shifted. All right. Now, the only other thing we haven't talked about, but is well worth taking a moment to remind you about, is that circle trig is something that helps us to figure out these answers when we're doing them in our heads. And so it's important for us to revisit circle trig. I'd like you to try this one. If the cosine of some angle is equal to 1 over the square root of 2, and let's make it negative to add a little more challenge, then figure out what two angles would work. Pause me, give it a try. Okay, so first off, I like to do ASTC, all students take calc, and that's telling me where things are positive and negative. I want cosine to be negative, so I can't be here because all of them are positive there. And I can't be here because cosine is specifically positive there. That leads me to make my triangles here, and the other one will be down in the t quadrant. All right, so cosine is adjacent. This is the key angle here. Adjacent, -1 over hypotenuse, square root of 2. And this other side is 1. Oh, it's 1 square root of 2. We haven't done that triangle in a while. Okay, so what is that triangle? That's the 45, 45, 90 triangle. And I'm going to cry a little bit and have to mark it wrong if you say it's 45 degrees, because this is 45, but this whole thing is a lot more than 45. Okay, so the angle we're looking for also should be in radians. And so 45 is really pi over 4. And so how many pi over 4s do I have to get to this spot? Well, it's not 4 pi over 4. That'd be all the way to here. So it's one less than that. So it's 3 pi over 4. And then you don't have to recreate everything down here. You just know there's also one down here. And that would be, well, more than 4 pi over 4. It would be 5 pi over 4. Because if it was 3 pi over 4 to here, and then 4 pi over 4 was here, then this would be 5 pi over 4. Well, there's your two answers for what that angle would have to be. Okay? All right. I hope this was useful. You can always stay in the chat room and afterwards and talk to me more in the Google Meet, and I'd be happy to do some more practice with you there. I really encourage you to study for this test. It'd be great if you start off on a positive note. Take care. Bye-bye.